Good morning, e-learners. Why would they be poor? They're sitting at home with food.
Little turds.
Yeah, they could be just sleeping right now.
They could be, and since there's no one live right now, they probably are. My afternoon class is always popular, though. I always have people in that one. All right. I need my geometry book. Number 14. Number 14 says there's 3 sisters. 2 of them are athletes. 2 of them like tacos. Who doesn't like tacos?
One of the sisters.
Yeah, but who doesn't like tacos? All right. 2 of them are athletes. 2 of them are tacos. Can you be sure that both athletes like tacos? All right. Are you reasoning deductively or inductively? Well, here's the idea. You have, watch me, how many sisters? So I'm going to just draw a square for each sister. It says that 2 of them are athletes and 2 of them like tacos, right? So does it matter which 2 I label as athletes? Okay, so I'll just make the first 2 athletes. The issue is that 2 of them like tacos. So if I put a T next to it, pick one, any one, likes tacos. The issue is now I got to have one other one. So the question reads, can you be assured that one of the athletes like tacos? You tell me. Yeah, so did you use inductive or deductive reasoning? Deductive reason is what we use in the geometry book. Inductive reason is the one that, yeah, it probably is true, but we don't know for sure. We use deductive reasoning right there. Like we just proved through a diagram that one of the athletes, it could be 2, but at least one of the athletes like tacos. So we use deductive reasoning right there.
And despite, even if it was not, it's not.
No, because there's a couple here that are inductive, right? Hey, every time I go to my car, it's raining. So tomorrow I better bring an umbrella because it's going to rain, right? That's inductive reasoning, right? There's no guarantee it's going to rain tomorrow, right? However, if you said something like, hey, I leave my classroom at noon every single day, the sun is out, right? Tomorrow the sun's going to be out at noon. That could be a deductive reason, because you could say, well, we live on the Earth. We're in the northern, we're north of the equator. We live at this particular latitude. The Earth spins. Or you could make that into a deductive reason instead of inductive reason. All right. Any other questions? All right. Here we go. Number what's it? Oh, okay. So number 1, the next 2 numbers were 256 and 1,024. I'm going to tell you there's going to be 1 inductive on the test tomorrow. Number 2 is 6 and then 3. Number 3 is 1 over 81 and 1 over 243. If the numbers are getting smaller, you're either subtracting or you're dividing. In this case, we're dividing. Number 4, 25 and 36. Stop passing notes, please. Number 5, 17 and 23 is the next number. Number 6, 40 and then 52. Number 7, 15 and then 4. On number 7, are we subtracting or are we dividing? On number 7, are we subtracting or are we dividing? We are subtracting. Number 8 is negative 1/4 and positive 1/8. I'm going to warn you. The sequence of numbers that goes positive, negative, positive, negative, positive, negative is almost always you're multiplying by a negative number. There is a case where you could add something, but it will only flip-flop once or twice, and then it'll either stay positive or stay negative if you're adding or subtracting. The only way it goes positive, negative, positive, negative, positive, negative, if you're multiplying by or dividing by a negative number. Number 9 is 500 and then 250. Who got 1 through 9 completely right? Every one of them. Okay.
What was number
9? 500 and then 250. Okay. Questions 1 through 9 are like what will be on the test. All right. Let's see. Number 10. Chan is older than Sarah. Number 11, you can't reach any conclusion on that. There's just not enough information there. Number 12, the polygon has 7 sides. Number 13, you can't conclude anything. Number 14, we already figured that out. We were figuring out deductively. And then number 15. 15, the next number will be 1, 1, 1, 1, 1. Number 16, the next number will be 8, 8, 8, 8, 8. And the last number is large, which is, that's right, 2 9s, is it 2 8s? No, 3 9s, 1 8, 3 zeros, and a 1. And that was it. Cool. All right, I'll collect that here in just a second. So for those of you who had me in the past, most of the time, not always, and especially not in geometry, most of the time when I give you a chapter review or a practice test, I make the claim that it looks exactly like the test. I'm not, what do you have on your head? I'm not lying this time. This is the test, like no joke. This is the test. Tomorrow it will look exactly like this with one exception, and that's going to be tomorrow it will have different numbers and it will have a proof. This is what you need to do in order to get at least, or if you get them all right, you got B, right? To get to an A, you got to get the proof right as well too. If you make any mistakes, then your B kind of could turn into a C. So just what you see in front of here, at a minimum, could get you to a B if you get everything right. The proof right will get you at least to an A, or partially right will get you to an A. My concern is that you're gonna not really think, the new kids, you're not gonna really think that my tests are, I'm not lying, this is the test, right? So you will know today, like right now, whether or not what your grade is gonna be, because you're gonna do these problems. Here are the answers, by the way, on everything. You're going to know what your grade is today. In fact, you can tell me, hey, I got an A on this. Well, I can put an A in the grade book and be pretty sure, minus the proof, that you'd get the same grade. If you do this and you're getting them all wrong, right? Just tell me that so I don't need to grade your test. No, I don't mean it like that. I mean like this is your last chance for help. So I do tutoring on these days, so if you're really concerned. And I'll just warn you on the ones for external and internal angles of the polygon, no joke. I'm going to give you the names, and you've got to be able to make sure you know the names. If I say hexagon and you don't know how many sides, even though you know how to calculate the internal and external angles, you're going to get the question wrong simply because you don't know what a hexagon is. So make sure in your book of truth that you have all that stuff written down. All right, so just a couple quick notes. It's not clicking. Couple quick notes. Test tomorrow, and then we'll do an algebra review on Monday, and then move on to chapter 4. We're already in chapter 4. This is everything that we did in chapter 3 that I will test you on. Everything. Now, some of these are from chapters 1 and 2. Adjacent angles that form a line, 180 degrees. That's not chapter 3. That's chapter 1. Vertical angles, that's chapter 2. So these two things from chapters 1 and 2, and then everything else from chapter 3. Two lines that are parallel cut by transversal, you get corresponding alternate interior, same side interior angles. You got to know. The first two, they're congruent. The last one, they're same side interior angle, they're supplementary. Exterior angle of a triangle. The exterior angle is equal to the sum of the two remote interiors. And then lastly, with polygons, you need to be able to calculate 4 different things. The sum of all the interior, you listen to that? The sum of all the interior, the sum of all the exterior, and then how much is 1? I tried to make it really clear on the test of what I want. If your reading comprehension is weak and you can't tell the difference between the word, what is the sum of all of the angles, plural, and what is the sum of one of the angle, or how big is one of the angles? Well then, I'm sorry, I can't help you there. You got to be able to read carefully. Lastly, inductive reasoning, the one that you just had, and I told you, I'm going to give you a sequence of numbers. You just got to give me the next 2 numbers. Okay? I can't really tell you exactly, which one Once again, if the numbers are getting bigger, you're either adding or you're multiplying. If the numbers are getting smaller, you're either subtracting or you're dividing. If the numbers flip-flop back and forth, it's getting bigger, then it's getting smaller, getting bigger, getting smaller. That's a combination of things. Adding, subtracting, multiplying, subtracting, something like that. But there will be a pattern, and it will be a recognizable pattern. It should be an easy question. And then lastly, I will put, not proofs plural, I will put one proof. And unlike the last one on the last test where I guided you through, I'm going to give you nothing other than the proof itself. I spent like a solid 30 minutes, like what proof do I want to pick for them? I picked a proof that all of you can do. Not a single person here can't do the proof. You got to write it up correctly. You got to make your statement. You got to give me your reason. But I picked a proof that is easily done. It won't take much thought behind it. So this is chapter 3 of the last easy one that I put, and the rest will be a bit kind of more of the medium. But the proof will separate my B's from my A's. Right? If you can do this sheet in front of you and checking your answers, you can be confident that you're going to pass the test. No surprises on this test. Questions? All right. Yes.
I'm looking confused on how to find one exterior angle.
Okay, an exterior angle. In general, what is the sum of all the exterior angles? Always. So if we're finding one, it's 360 divided by how many sides we have.
Okay.
So if it's a pentagon, you're dividing by 5. If it's an octagon, you're dividing by 8. If it's a 14-gon, then you're dividing by 14. It is the easiest one to do. Can you use a calculator on the test? Absolutely. Is a calculator going to tell you the right answer? No, not if you don't know what you're doing. Geometry is not a calculation-based math. It's a logic-based math. So that's why I allow a calculator. Algebra 2, most of the time you can use a calculator. And then pre-calculus, calculus, you use calculator all the time. Right? You're way past this silliness of, oh, let me test you on, can you multiply 2 decimal numbers together, which I literally am doing in 7th grade right now. They can't use a calculator. But if you make it to 10th grade and you can't multiply with decimals, then sorry, all right? Better always have a calculator with you. All right, any questions? All right, use this time wisely. Yeah. Give you a proof? Well, I mean, the issue with proof is this. I can give you tons of proofs, and it's not going to help you get the one on the test because it's going to be a different proof. So that's the only issue with proof. In general terms, we do proofs every day in class other than like a review day. So you're going to get plenty of practice for proofs, and I think you're going to be fine on the one that I give you. In fact, you're probably going to want a more challenging one than the one that I give you. Cool? All right. All right, e-learners, I'm going to stop it right here. I will have the test posted by 3 p.m. tomorrow. So if you're looking for the test to take it tomorrow, it'll show up by 3 p.m. 3 p.m. If you have any questions, make sure you ask.
It's not fair to get study time.
Well, considering that not a single one of them is live right here, they probably get the same amount of studying time.